Alright, we're going to start a completely new topic in this next unit. So here's the I can statement for section 11.1. I can identify and solve problems using adjacent and vertical angles. So adjacent, that's A-D-J-A-C-N-T, adjacent and vertical. And make sure you spell vertical correctly. It's not C-L-E, it's C-A-L, vertical. Just like horizontal, when we get talking about things that are horizontal, that's T-A-L, and vertical is C-A-L. All right, so this unit is going to be about geometry, and as a warm-up, we're just going to start talking about some of the things that you already know about geometry. So when somebody says, well, what do you know about geometry? A lot of people will start talking about, well, let's see, there are points in geometry. We talk about lines, planes, meaning those flat surfaces, angles, which we're definitely going to do a bunch of talking about, shapes, figures, things like trapezoids and triangles and squares and different things like that. A lot of different things like that. And then you might also think, well, in geometry we use, let's see, straight edges. That's a ruler. Okay, the difference between a straight edge and a ruler. Straight edge has just got the straight edge on it, and a ruler actually has the marking so we can measure things. Protractor. That's that little kind of half circle thing that allows you to measure angles. And then a compass. A compass is that thing where you can put a pencil in it and then you can swing it around and make a circle and arcs and different things like that. So those are a bunch of the things that we know about geometry. Hopefully some of those ring a bell. And the word geometry actually means earth measure. So geo means earth, and metry, it means you measure something. So when we say geometry, we're talking about earth measure. And there are lots of things like this: points, lines, planes, angles, a lot of shapes in the real world and on the earth that we live in. So when we're working with geometry, we need to make sure that we understand not only the notation, because there's tons of notation in geometry, but we also need to know what the vocabulary is. Because just like every other branch of math, if you know the vocabulary, it goes from being really confusing and scary to, oh, okay, I think I can do this because I know what the words mean. So we usually name, and we're going to start out just reviewing some things, we usually name points, because that's about the most basic geometric figure, using capital letters. Capital letters. And you'll notice that I've got some points down here, and we've got 2 points. We've got points A and B right here, and these 2 points define, because there's an arrow on each end, these define a line. And the way we would indicate that line is we'd do an AB with a line over it. That's the notation that we'd use for that. Now this one right here, hopefully you recognize this one. This is a ray, so it starts at this end point and then it goes on forever through that other end point. So that's a ray, and the way we would indicate that is we draw a line with an A to a B, and then we'd go like that. This right here, because it has 2 endpoints, it doesn't go on forever in either direction. This is called a line segment, or sometimes we just call them a segment. And to indicate a line segment, we're just going to do an A with A and B with a little segment over the top of it. Now, if 2 points define a line, then 3 points can define an angle. 3 points can define an angle. Okay, so we've got the points B, A, and C, and they define an angle. And normally when we're talking about an angle, what we're talking about is we've got a ray right here and we've got a ray right there, and they kind of swing apart to open up this little interior area, and that we call the angle. Now, it is possible to be talking about this big angle on the outside, but normally, unless we're told otherwise or there's some way to figure it out, when we're talking about an angle, we're talking about that little angle on the inside. Now, in order to make things consistent and kind of standard, we need a way to label and measure our angles. So I want you to take a look at this right here. So this is very typical. We've got a copy of that angle right here, and then there are several different ways that we can name that angle. We can name that angle angle CAB. And this little symbol right here, that little tiny angle, literally means we say the word angle when we see that. So we're talking about angle CAB. And the reason we can call this CAB is C is on one of the rays, A is at the vertex, and then B is over here. So we're literally going from C to A to B to kind of mark out where that angle is right there. Another way that we could describe that would be angle BAC. So BAC, start at B, go to A, and then end at C. Now, because of the way this angle is drawn, it's kind of off by itself and stuff like that. It's not near anything else. We could also label this as angle A. We could just say it's angle A because we name it according to where the vertex is. And you'll notice that the A is in the middle of each one of these lists of 3 points. So CAB and BAC. It's just a question of whether you go this way or go that way. Okay, so usually we would just say angle A. If we can get away with that, we just go ahead and put angle A. That's probably the best one. And reminder that the corner of the angle, and I think I already said this word, is called the vertex. The corner of an angle is called the vertex. We use the word vertex or vertices a lot when we're dealing with geometric shapes and figures and different things like that. I do have a quick question for you. What if I said this, angle ABC? Now those are the same 3 letters there. Is it possible to label this angle or talk about that angle as angle ABC? And the answer to that is no, you can't do that. And the reason you can't is because you'd have to start at A, go to B, and end at C. That would be talking about this angle right here. So whenever you're indicating what angle you're using, make sure you use the right terminology in the right order, and make sure that that vertex is at the corner there and in the middle of your list of 3 points. And another thing that we'll need to be aware of is the most common way that we measure angles. We usually measure angles using degrees. So I'm going to write degrees right here. And the symbol that we use is a little open circle that's written superscript. So we write it above. So if I were to say something like 45 degrees, for example, I do 45 degrees. It's just like we do the temperatures in an oven or something like that. Okay, so a little symbol right there. Little small open circle written up above and behind the number. So it looks like that. Now let's talk about some of the common angles that we'll be dealing with and some of the vocabulary here. So let's talk about acute angles. Now I would imagine that you've heard about this before. Acute angle is an angle that measures less than 90 degrees. Notice I put the degree symbol on there. A right angle is an angle that measures exactly 90 degrees. An obtuse angle is one that measures more than 90 degrees. And then a straight angle. Now you may or may not have heard of this before, but a straight angle. Well, if we put 2 90-degree angles together, if I've got a 90-degree angle like this and another 90-degree angle right there, if those are both 90 degrees, and then that's the symbol that we use there, a straight angle measures 180 degrees, because if there are 90 right here and 90 right here, a straight angle measures 180 degrees. So it's just a straight line, and we've got those 180 degrees over there. Okay, let's take a look at this next part. Couple quick examples. Now, like I said, mathematicians, a lot of times they're lazy, but they like to do things accurately, but they want to make things as efficient as possible. So on this example right here, this literally, when we have this kind of cursive M right there, it literally means the measure of angle A. So it wants to know what is the measure of angle A. So here's angle A. The measure of angle A is 20 degrees. It's literally that simple. If we want to know the measure of angle B, the measure of angle B is 127 degrees. So again, practice writing that little degree symbol so that it looks right. And then this one right here, now again, that little mark of a square right there, that means that this is a right angle, so that one is 90 degrees right there. So I'm going to run through and label these. I didn't ask you to do that, but this one is acute, this one is obtuse, and this one is a right angle. And again, that little symbol right there, even though we didn't have the number of degrees right there, that little mark of a square right there indicates that that's a right angle, so that's got to be 90 degrees there. Now, knowing about right angles and degree measure can help us understand some basic principles in geometry. So, like I was mentioning before, how many degrees are there on one side of a straight line? So if we were to do this, like I mentioned up above, if that's a right angle and that's a right angle, if this is 90 degrees and this is 90 degrees, On one side of a straight line, I've got the two of those together, so that's going to be 180 degrees. So on one side of a straight line, we've got 180 degrees. Well, I could do the same thing down below, so those would each be 90, and then this would be 180. So if I went all the way around full circle, so if I started right here and opened up an angle that went all the way around, came all the way around to there, that's going to be 360 degrees. And that's not any surprise. A lot of us have hear about doing a 360 or 180 and stuff like that. So here's the interesting thing. If there are 360 degrees all the way around, I can use that information to figure some stuff out. So let's say, for example, this angle right here is 180 degrees. Or sorry, 100 degrees. Now this straight line right here, there's 180 degrees on this side of the straight line. So that means this one over here has to be 80. And then I can do the same thing with another line. So let's take this line right here, and then I'm looking over on this side. Well, on this side of that straight line is 180 degrees, and if 80 of them are used right here, there's got to be 100 degrees right there. And then I can do the same thing down below. If this is a straight line right here, there's got to be 180 degrees below this line, so that means that one's got to be 80 degrees. So there's some really cool things that we can notice if we know how to measure angles and lines and all that sort of stuff. Now, we are going to need some more vocabulary for today's stuff, and this is really what we're going to focus on. Remember, the I can statement was about adjacent and vertical angles. So let's talk about adjacent. Adjacent angles are angles that are right next to each other. You have a neighbor probably right now sitting next to you, or even at home, your neighbor's house is probably adjacent to your house. It's next to your house. Okay, so the word adjacent is just a fancy word that means next to. And then the other word is vertical angles. So vertical angles are pairs of opposite angles made by two intersecting lines. Okay? Now, we're going to use lowercase letters to represent the measure of an angle. So in this diagram over here, I've got a lowercase a and a lowercase b and a lowercase c and a lowercase d. So these are all lowercase, and they're going to represent the measures of the angles. So this is how much angle A measures and angle B and so forth. And it says name all the pairs of adjacent angles. So remember, adjacent angles are the ones that are next to each other. So we could go through and we could say, well, A and B are next to each other. So I'm going to do A and B. Those are adjacent. They're next to each other. We could do B and C. We could do C and D. And the last pair would be D and A. Okay, and I'm going to put it like that just so we can kind of see that we were going around the circle this way. There are no other pairs of adjacent angles. There aren't any others that are right next to each other. And when we say right next to, what we mean is they share a side, they share a ray, or they share a segment. Okay, so I'm going to write that they share a side. All right. Now, name all the pairs of vertical angles. So part B, name all the pairs of vertical angles. So vertical angles are pairs of opposite angles made by two intersecting lines. So we've got these two intersecting lines here. So let's take a look. The vertical ones would be the ones that are opposite of each other. So this one and this one, they are opposite from each other. So we're going to say A and C would be a pair of vertical angles. They always come in pairs. And then if I look at this one right here, B and D, those are vertical angles because they're across from each other. So we're going to write B and D. So those are the pairs of vertical angles. Now, just got to keep those straight. That's the focus of this section. So adjacent, they've got to be right next to each other. In other words, they share a side. And vertical angles, those are the ones that are opposite from each other. So we're always talking pairs of vertical angles and pairs of adjacent angles. Now we're going to go ahead and flip the notes over. And this is the cool part about this particular section. All you have to do is name the relationship between angles A and B. So in each one of these diagrams, there's an angle A and an angle B, and all you have to do is say, okay, what's the best name for this? So if we look at this one right here, now this one has an extra line in it. This line right here isn't needed to make angle B and angle A. But you will notice that this line right here and this line right here form the two of those. They kind of share the same vertex, not the same side, and they're opposite from each other in that intersection. So the best name we could give to this would be vertical. Vertical, make sure you're spelling that correctly. If we take a look at the two of these, now there's an extra line on here, so we've got a straight line here, there's 180 degrees on one side of the straight line, but the only thing we're interested in here is the fact that those two things are right next to each other. So angle B is right here, angle A is right here, and they share that side right there. So these are adjacent. So those are adjacent angles. That's the best name we could give to this. Bunch of extra sides and shapes and things going on here, but take a look. A and B, they are across from each other. They're opposite each other as these two lines intersect. So that's going to be vertical. Again, that spelling there. And then we take a look at this one. Extra line over here that we don't even need to pay attention to, but this is a straight line, and this angle is formed by that line, and this one is formed by that line and that line. So they share this side right here, so this one's going to be adjacent. Okay, so we've got the four names there. Now, I want to see if you caught something as we were talking about vertical angles. I've got this diagram right here, and I'm going to do this. We've got a straight line here and a straight line here. I'm going to label one of them. I'm going to label this one as 130 degrees. So 130 degrees here. Now, on one side of a straight line, so I'm going to do the top side of the straight line. On the top side of the straight line, there's 180 degrees. So if this one is 30, let's see, 180 minus 30, this one here's got to be 50. And notice that they make a straight angle, they make 180 degrees, so we should be in good shape there. Now I'm going to do the same thing over here on this side. This is a straight line, so there's got to be 180 degrees over here. If 130 degrees are right here, then this one's got to be 50 over here. And then I can do the same arithmetic either with this side or with this side. It doesn't make any difference. This one's going to end up being 130. So what do you notice about the vertical angles? So these two are vertical angles. I'll highlight those. And these two are vertical angles. I'll highlight those. So take a look at that. And then I'm going to come back here and let's take a look at, I actually did this just a second ago. I did this right here without even using the vocabulary or the names, and you'll notice those two are vertical angles, and you'll notice that those two are vertical angles. So do you notice anything about vertical angles? Well, here's what we ought to notice. Vertical angles are always, and here's the word that we use for this, the word is congruent. Vertical angles are always congruent. And congruent is the geometry word for equal. Okay, meaning they are exactly the same. So if they're exactly the same, that means their measurements have to be the same. So if this one's 130, its vertical pair, okay, the one straight across from it has to be 30. And if this one's 50, the one straight across from it, the one that's vertical with it, has to be 50 also. Now, to remember the name vertical, I mean, sometimes we just draw lines that look like that. They kind of make a V shape. This one right here would be vertical with that one right there, and this one right here would be vertical with that one right there. So when we've got that V shape, that V that's formed by two intersecting lines, we know that kind of stands for vertical, and the ones that are opposite each other, those are going to be vertical angles. So we're going to come down here and we're going to use that information about vertical angles in order to figure this stuff out. Now you'll notice that on each one of these we've got a different diagram and we've got a bunch of stuff going on. This one is probably the simplest, and what it says here is find the measure of angle B. Now we want to look at this and we want to think, okay, what do we know about gosh, they're just two intersecting lines. Those are both vertical angles. Well, that means this one has to be 43 degrees because vertical angles are always congruent, okay? So on this one, all we had to do is just figure out what the answer was as far as the measurements. So we've got 43 degrees right there. Now this gets kind of interesting. We've got 209 degrees here, 96 degrees, and we want to figure out what this one right here is. We don't know what angle B is. So these do happen to be all next to each other, and if you stop and think about it, if we go all the way around, so if we started at B, went to 96, and then went to 209, if we went all the way around there, that would be 360 degrees. So what that means is angle B plus 96 plus 209 has to be equal to 360 degrees. And then we just solve this really quickly. So we're going to add the two of those together. So if we add those together, let's see, we're going to get b plus, just combining some like terms here. That's almost like adding 100. That would be 309, but we get 305. And that equals 360. Oops. And then we're going to subtract 305. And then those are going to cancel, so we get b equals, this is 55 degrees. So that one right there is 55 degrees. Okay, and if you went through and you added 55 plus 96 plus 209, you would end up with the 360 degrees that it takes to go all the way around the circle. Okay, this one is a little bit more complicated than that one right there, but we use the same idea. Now, if you can, ignore this line right here that's not used at all. Look, that 90-degree angle is formed by this line and this line. So if this one is 90 degrees, this one over here has to be 90 degrees because they're vertical angles. Okay, so I'm going to put vertical here and vertical here. Now, about the best name we could give to this isn't very specific, but you'll notice that all of these share sides. So we could say that these are adjacent. Okay, and in this particular case, they're adjacent, and we know that they add up to 360, so we're in good shape there. Same thing's going to be true right here. We've got B, we've got 205 degrees here, and then another 127 right there. So the best name we could give to that would also be adjacent. And the thing that we know about them is if we add them all together, so if we add up all three of those angles that make kind of that full circle, we should end up with 360 degrees. So let's see, this is going to be b plus, let's see, if I add those together, I end up with 332, whoops, plus 332 equals 360. We make that look right, subtract the 332, so we get b equals 28 degrees. So this angle right here is 28 degrees, so I'll circle each one of those answers there. Okay, that's the idea. We're basically just getting used to some of the terminology, the vocabulary, the way we indicate the measure of an angle, and really the focus here is, do we have vertical angles, and then we know they're congruent, or do we have adjacent angles, they're next to each other, and then we can figure out, based on the diagram, how we can figure out what that missing angle is. All right, good luck.